Hello everyone, how to solve n to the power of 4 minus n cubed minus n plus 1 equals to 0, and we solve this problem for the values of n. So the very first thing we are going to do is here first we rewrite this equation as n to the power of 4. We write n to the power of 4 and plus 1, and we make the pair of n to the power of 4 with 1, and we make the pair of n cubed with minus n, and we first take common minus from both of the terms, and you get n cubed plus n equals to 0. And now in the next step we move this n cubed plus n to the right hand side, and we get n to the power of 4 plus 1 equals to n cubed plus n. So in the next step we divide both of the sides by n cubed plus n, and we write it as uh, we first divide here n cubed plus n, and in the right hand side we divide n cubed plus n. And now you focus on the right hand side, and you see that these two terms are cancelled by each other, and we obtain n to the power of 4 plus 1 over n cubed plus n equals to 1. And now in the next step we just take common n square in the numerator, and we take common n square from the denominator. So now first we take common n square in the numerator, and you write n square into n square plus 1 over n square, and it is divided by, here we take common n square in the denominator, and we get n square into n. When you take common n square you get 1 n, and here you take common n and you divide by 1 over n, and it is equals to 1. So in the next step you see here this n square are cancelled by each other, and we obtain n square plus 1 over n square in the numerator, and similarly you write it as n square plus 1 over n square in the numerator, and it is divided by n plus 1 over n equals to 1. And now in the next step we convert this nice equation in the completing square form. So now first we focus on the numerator, and we have n square plus 1 over n square, and in order to make the complete square we add or subtract some term, and we write it as n square plus 1 over n square, and we add 2 times of n into 1 over n, and similarly we subtract this term 2 times of n into 1 over n, and it is divided by n plus 1 over n, and it is whole equals to 1. So now in the next step you focus on n square plus 1 over n square plus 2 times of n into 1 over n. So we make the complete square of combine the these terms. So when you combine these terms, then you get here n plus 1 over n whole square. So we write in this way, n plus 1 over n whole square, and this is n is cancelled by this n, and we have minus 2, and over we have n plus 1 over n, and it is equals to 1. So now in the next step we convert this nice equation into the quadratic form. So we take the n plus 1 over n equals to some variable which is denoted by y. So we have it is equals to n plus 1 over n, and when we substitute this value of y in the up or numerator, then you get its output in this form, y square minus 2 over y, and it is whole equals to 1. So in the next step we move this y in the right hand side, and we get y square minus 2 equals to y, and now we move y in the left hand side, and you get this equation in standard form, and we have y square minus y minus 2 equals to 0. So in the next step we just find the factors of this equation, and the factors of this equation are y square minus 2y plus y minus 2 equals to 0, And now we take common y from the first two terms and you get y times of y minus 2, and here we take common plus 1 and we get y minus 2 equals to 0. And now in both of the terms you see that we have y minus 2 be the common factor, so that we take common y minus 2 here, and you get y minus 2 times of y plus 1 equals to 0. So here we have two cases. The first case is we write y minus 2 equals to 0, and the second case is we write y plus 1 equals to 0. So in the first case you get the value of y equals to 2 and you get the value of y equals to minus 1. So now we back substitute the value of y, and in the above you see that we put y equals to n plus 1 over n. So we substitute this value here and you get n plus 1 over n equals to 2, and here you have n plus 1 over n equals to minus 1. So now we convert these both equations in standard form, so that we multiply both of these cases by n on both of the sides. So when you multiply the first case by n, then you get here n square plus 1 equals to 2 times of n, and the second case you get n square plus 1 equals to minus n. So now we rearrange the terms and we write it as n. In the first case we have n square minus 2n, we move 2n in the left hand side and plus 1 equals to 0. Similarly here you get n square plus n plus 1 equals to 0. So now we make the factors of both of these equations and we get the values of n. So now first you focus on the first case and we have n square, we break minus 2n and we write minus n plus 1 equals to 0, and we take common n on the first two terms and you get n times of n minus 1. Here we take common minus 1 and you get n minus 1 equals to 0. And now we take common n minus 1 on both of these cases and you get n minus 1 times of n minus 1 equals to 0. So you have n equals to 1. So this is the our first real root of the above given equation. So now in order to find the other roots we need to solve the second case. So in this case we use here the quadratic formula, and in order to use the quadratic formula first we write the exponents of this equation, and we have a equals to 1, b equals to 1 and c equals to 1, and the quadratic formula will be written as minus b plus minus a square root of b square minus 4 times of ac divided by 2 times of a. Now we substitute the values of a, b and c here. Then you move towards our final answer and we have n equals to the value of b is 1 and it is minus 1 plus minus 1 minus 4 times of a is 1 and c is 1 and its square root divided by 2. So we have n equals to minus 1 plus minus 1 minus 4 equals to minus square root 3 over 2, and you know that when negative sign occurs inside the square root, so it will becomes iota, and we write it as minus 1 plus minus square root of 3 times of iota divided by 2, and this is the other two complex roots of the given equation, and this is the final answer.